Lesson 52 is on maximum and minimum problems. So we are going to be analyzing word problems and either maximizing or minimizing something. And this is an important concept in calculus. You can download and print the template on Schoology so you don't have to copy over all the word problems. All right, so our first example says this. Find two non-negative numbers whose sum is 9. So the product of one number and the square of the other number is a maximum. So in doing this problem, what we need to do here is define what our variables are going to be first. So we have two non-negative numbers. I'm going to call one of them x and one of them y. We know that the sum is 9. Therefore, x plus y is equal to 9. And also the product of one number, so it doesn't matter which one, I'm just going to do the first one. The product of x, so we have x and y, and the square of the other, so if I take the other and square it, if I now multiply these together, because that's what product means, what we want to do is find a maximum. So I have x times y squared. And it doesn't say what that equals, so I'm just going to call it something, and I'm going to call it P for product. And what we want here is we want to maximize this. So we want the maximum product possible. We now have two equations. We have three unknowns. We can now go back to one of these equations, and the first one will be the easiest one, and we can take and solve for either x or y. So let's go ahead and just solve that equation for x. And in doing so, I would just subtract the y from both sides. So I would get 9 minus y. Now I'm going to go to the second equation, and instead of x, I'm going to replace x with what x is equal to, the 9 minus y. So now I have this equation using substitution. And when I solve this, I'm going to distribute. So now I have 9y squared minus y to the third is equal to p. Now this is the equation that I'm going to use from this point forward. What I want to do is I want to maximize something. We know to maximize or to minimize something, either way, is finding a turning point. So going from an increase to decrease or decrease to increase. We also know that happens when the derivative is equal to 0. So what we're going to do once we get this far is we are going to find the derivative of p, so p prime. And in doing so, I get 18y minus 3y squared. And if I now take and set this equal to 0 and then solve, I would then know where that maximum or minimum is. Again, I'm looking for the max. So I'm going to factor out a 3y. And in doing so, I'm going to get 6 minus y, and that's equal to 0. And now I'm going to set each part equal to 0. So I'm going to set 3y equal to 0, which you're going to see I get an answer of y equals 0. And I am going to take and set 6 minus y equals to 0, and you will see I get an answer of y equals 6. Now I have two solutions here. Here is where the maximum part comes into play. I want to find a maximum. We have two ways you can do this, and I'm going to do it using my second derivative test. If I now go and find the second derivative, or p double prime, what I'm going to get is 18 minus 6y. If I now take and plug in my values of 0 and 6, what I'm going to get is, for 0, it looks like I'm going to get 18. And p double prime, oops, this is supposed to be 6. When I plug in 6, it looks like I'm going to get 18 minus 36, which is going to give me a negative 18. Now remember, the second derivative tells us concavity. It tells us if it's concave up or concave down. If something is positive, it is concave up. And when something is concave up, it has a minimum. So we're not looking for that one. If it is negative, it's concave down, and that one has a maximum. So the one that we're looking for is, or what our answer is going to be when y is equal to 6. So now we know that our y value, or one of our numbers, is going to be 6. And yes, that is a non-negative number. And now we need to determine the other one, and we can go to either one of these equations, and I'm going to go to the first equation because that's definitely the easiest. You can see then that x has to be equal to 3. So there are my two answers. I have y equals 6 and x equals 3. And those two are the largest numbers that I can get that fit the two circumstances as described in the problem. All right, taking a look at this next problem here. It says we're building a rectangular pen with 3 parallel partitions using 500 feet of fencing. We've drawn this picture many times. And the question asks us right here, what dimensions will maximize the total area for the pen? So first of all, let's go ahead and draw the picture. It's going to look like this. I have 3 parallel partitions right here. And we know we have a perimeter is 500. So I need to call one of these sides x and one of them y. So I'm just going to go ahead and call this whole side x, and this will then be y, and of course all of those are y. I can now come up with an equation with perimeter. Again, we've done this many times. We have 2x plus 3y is equal to 500. And what I'm trying to do is maximize the area. I know the area is equal to x times y. I also know I can, before I take the derivative of this, I have to have everything in terms of either x or y. So I'm going to go back to this equation right here, and I will solve for one or the other. And in this case, what I'm going to do is I'm going to solve for x. The reason I'm going to solve for x is because if I solve for y, I would have to take and divide both sides here by 3, or everything by 3, and look at everything as a fraction. I would have a fraction here, a fraction here. So if you can find a way to not introduce fractions, that's the best. And when that will happen is when we solve for x, because if I divide by 2, the only place I get a fraction is right there. So I'm going to take that equation there, and I'm going to solve for x. And when I do, I'm first going to get, well, I'll show you my work here. I have negative 3y plus 500, and now dividing by 2, here's what I have. I have x is equal to negative 3/2 y plus 250. I'm now going to use this equation, and I'm going to replace that x. So now I have the area being equal to negative 3/2 y plus 250, and all that times y. And of course, I want to distribute to simplify. So what I have for the area is negative 3/2 y squared plus 250y. Now, this is the equation that I'm going to use. I'm trying to maximize something. To maximize or minimize again, we want to find the derivative, set it equal to 0 because that's a turning point, and then determine through the second derivative if it's a maximum or a minimum. So let's find a prime. In doing so, I get negative 3y plus 250. And if I set that equal to 0, I'm only going to get one answer here. Because when I take and divide by 3, I do get a fraction. What I'm going to get is y is equal to negative 250 over, divide by negative 3. I'm like, why is that negative? All right, a positive. So what I get is y is equal to 250 over 3. Now, let's just go ahead and make sure that this is indeed a maximum. So again, I'm going to find the second derivative. So going back here, I'll find a double prime, and I get negative 3. Okay, negative 3 means it's concave down. Concave down means I have a maximum. So I know that's correct. You should still check even though you just have one solution, because you could have made a mistake. So what I now have is my y value, 250 over 3. I want to leave it as a fraction. And then I need to find my x value, so I'm going to go back to one of my equations. I'm going to use the top one, And I will go ahead and I'm going to change colors here. Plug in 250 over 3 for the y. That simplifies away. That's great. So I have 250, or 2x is equal to 250. So I get x is equal to 125. So there is my x value. There is my y value. So I am going to just make sure I put units on this. So it's 250 over 3 by 125, and this is in terms of feet. There's my answer right there. It says what are the dimensions, and I did find the dimensions, so I am done. All right, number 3, an open rectangular box with a square base is to be made from 48 square feet of material. This is our surface area right here. That's finding the area of each side and adding them all together. The question asks what dimensions will result in the box with the largest possible volume. So we're trying to maximize the volume. So let's start by drawing a picture. All right, so there's my picture. And I know that my base, I have a square base. Square base means the length and the width are the same. So I'm going to call that x. So that's x, that's x. And then the depth or the height, I'm going to call y. Not the depth in this one, I'll call y. So we are talking surface area. So we need to find the area of the base first. So the area of this base is x times x, or x squared. And I don't have a great picture here, but the top is open. So this part right here doesn't exist. So there's just one that's from the bottom. I kind of drew my picture laying down. It should actually have been standing up. Now I'm going to find the surface area of the long side right here. And that is x times y. So that's going to be adding x and a y. And I have 4 sides of those all the way around. And this right here has to equal my total surface area, which is 48. Now I'm going to take this equation here in a minute and solve for x or y, and you're going to notice that definitely y is going to be the easier of the two to solve for. So we'll get there in a second. But first of all, let's find the second equation. And that equation deals with volume. So I know volume is base times height, or length times width times height. So I have an x times a y times an x, or the base x squared times y. So that's going to be x squared times y. Now going back to this top equation here and solving the equation for y, here's my y. And in order to solve this, I'm going to first subtract the x squared. And then I'm going to divide every term by 4x, and I'm going to do it individually. And then I'm going to simplify, and that's why I separated them and did them individually. So here I have 12 over x, and here I have x over 4. Oops, sorry. I put an equal sign there. It's supposed to be a minus sign. So that's what the y is equal to, that I can now take and replace with this y right here. So now what I have is the volume is equal to x squared times 12 over x minus x over 4. And again, to simplify by distributing, I have, well, one of these x's will simplify away, so I have 12x, and here I have x to the third over 4. Now, because I'm trying to maximize this, I'm going to find the derivative, and then I'll set it equal to 0. So this gives me 12, and this, remember, right here is the same as writing it is this, negative 1/4 x to the third. So when I multiply by 3, I'm going to get negative 3/4, and then subtract the 1 on the x, so x squared. And then I'll set that equal to 0. And when I solve that and add 12, I have negative 3/4 x squared is equal to negative 12. And to get rid of this fraction here, I multiply by the reciprocal. And you can see the two negatives are going to make a positive. This 3 is going to simplify away with the 12 and make that a 4. So what I now have is x squared equals 16. And to undo this, I take the square root usually you put plus or minus, but because I'm looking at a real life application in which I can't have negative values, I'm just going to have the positive one. So what I get now is x equals 4. Now I need to make sure that this is definitely a maximum, so I'm going to find the second derivative. So v double prime, that goes away. Right here I get negative 6/4, which could be reduced, times x. And when I plug in that value of 4, what I get is a negative value. And if it's negative, it's concave down, and that results in a max, which it better, because that's what I'm looking for. But you should, again, always check for that. So now I know that 4 is my answer for the x value. Now I need to figure out my y value. So if I go back to this equation here and plug in 4 for the x, I will get my y. And I could go any equation, but that's definitely the easiest. So now I have 3 minus 1, or a value of 2. So what I get is a 4x2 foot box. And there we go. And my apologies for this video being long, but of course this word problem takes a little bit more work. And this is definitely the hardest problem. It says find a point xy on a graph, so we're going to have to graph this, of y equals the square root of x nearest the point of 4 and 0. So let's draw that graph. Square root starts here, it goes up and over like this. And this, remember, is the equation y equals the square root of x. We need to find the point, or find the point that's nearest 4, 0. So what I do know is do know that 4, 0 is kind of like right about there. And I want to know which point on the graph is the closest to this. And again, so this time we want to minimize. So, and again, what we need to do is have our two equations, get it down to 1, take the derivative, set it equal to 0, and then solve. So when I'm taking and trying to find a point here and I want to minimize the distance to the line, I have to use the distance formula. So the distance formula, remember, it's the change in the x values, being squared, and then taking and adding to it the change in the y values and squaring it. So in doing this, I have right here, this is one of my x values and this is one of my y values. So I can call that x1, y1, or x2, y2, doesn't matter. And the other one is just the point x, y, right here. That's what I'm looking for. So what I get for a distance formula is going to be the square root of 4 minus x being squared plus 0 minus y being squared. Right here. And I know that what y is equal to is the square root of x. So I'm going to go and replace my y's right here with that square root of x. So what I now have is this. And 0 minus square root of x is just a negative square root of x. And if I take negative square root of x here and I square it, so if I take negative square root of x and I multiply it by negative square root of x, what you're going to see, negative and negative makes a positive, and the square root of x times square root of x is just an x. So this is going to be replaced with an x. And this here I will have to FOIL out. So write it like this and FOIL it out. I'm going to do it rather quickly. So it's 16 minus 8x plus x squared. And then I have the plus an x. And this is all under the square root. And when I combine my like terms here, and I'm also going to write it in descending order. So I have x squared minus a 7x plus 16 right here. And I have to now take the derivative of this. So in order for me to do that, I have to write this as a rational exponent. So I have to make all of this to the 1/2 power. And then I have chain rule going on here. So I'm going to start with my outsidemost function first, which is taking care of that 1/2. So it's going to be 1/2 x squared minus 7x plus 16 to the negative 1/2, followed by chain rule, which is the derivative of the inside, so 2x minus 7. This is my derivative right here that I now need to take and set equal to 0. And what I'm going to do to clean this up a little bit is I'm going to write this as a positive rational exponent. So this is going to be a 1 on the top. Everything there that's attached to it in the parentheses will go on the bottom. And then that 2x minus 7 is on the top. And the reason I'm doing this is because, remember, I'm setting this equal to 0. So when you set this equal to 0 right here, I now have one fraction equal to one fraction. So now I can just take and cross multiply, which is going to be the easiest way to solve this. Otherwise, I would have had a mess. So when I cross multiply right now, I'm going to get 2x minus 7 is equal to 0. And when I solve this, you can see I'm going to get x is equal to 7/2. All right, so I have my x value. Now I just need to determine my y value. And in doing so, I'm going to go back to my equation up here, and it says y is equal to the square root of x. So y is equal to the square root of 7 over the square root of 2. And the reason I'm separating that is because I have to rationalize the denominator. So this is the square root of 14 all over 2 is what the y is equal to. So there's my y, there's my x. I'm going to simply write that as an ordered pair. So x comma y right there. And that is the hardest type problem that you will have to deal with. And make sure you know how to do that, though, for the tests, because you will see a problem almost just like this on your next test. And with that, your homework is a worksheet, lesson 52 worksheet. On the front side, we got maximum and minimum problems. On the back side, it's related rates. Have a great day. Bye.